So when someone comes to us and says, what are the different types of equations of a line? It is important to recognize that we have a general form of the equation of a line, or I called it the standard form here, a general standard form of the equation of a line. We have the slope-intercept form of the equation of a line, and we have the point-slope form of the equation of a line. So we have three types of equations of a line that are very common in algebra classes. Let's start with the general form, actually, which is listed as the third. So please, let's put these in our notes. The three types of equations of a line. The first one is the standard form, which is, in this case, I just said ax plus by is equal to c. You can move that c over to the left side, and it'll become ax plus by minus c is equal to, well, depending on how you want to write it, you could technically have x, a y, and a constant. But in this case, we're not going to worry about that. We're just going to say ax plus by is equal to c, c, some sort of value. So maybe this is 2x plus 5y is equal to 12. That's an example of how this could happen. When do we use the general equation of a line? So this is page 94 of your college CLEP book, okay? The goal of this project, of this recordings, is to go through every single page of the CLEP book, so we're comfortable with every single concept. Even if we have to go back and review them again, that's fine. We just need to be comfortable with every concept, right? And so the general form of the equation is given. It's used especially when you're solving the equation systems of equations, where you have two equations and two variables, and basically you could use substitution or elimination. That's discussed in chapter 4 of the Tyler Wallace book. But the idea is that the standard form or the general form is used when solving systems of equations. So please write that down in your notes, that the general form is mostly used when solving systems of equations. Okay, when do we use the slope-intercept form, which is y is equal to mx plus b? We use that mostly when we're graphing, right? So here we use it when we're graphing. Here we use it when we're solving systems of equations. That's a very common use of it. The point-slope form can be very useful in finding certain values that you might be looking for, like the y-intercept from the graph, right? You can, if you have 2 points, you can work your way back well, you could find the slope that way, but you can also use the point-slope form to get the slope-intercept form of the equation of a line. So you can use the point-slope form to your advantage in certain situations. So there's a point to it, no pun intended. There's a point to the point-slope form, but just keep in mind that there's three types of equations of lines that are very common. So on page 94, all we need to note is that the general form of an equation of a line is given, and then they also give you the slope-intercept form. Just write those down in your notes and you'll be good to go. Then they give you a graph, and they ask you to find the equation of the line in the graph below. So they've given you a line, it intersects at -2, so you know the y-intercept right away, right? Y is equal to mx plus b, the b represents the y-intercept. So right away you know that that's the y-intercept, so you know that part in solving the equation. The other thing you need to find is the slope. How do you find the slope? Use the slope formula, which is just y2 minus y1 over x2 minus x1. So that's the slope, right? So we find the slope and we find the y-intercept. We found the y-intercept from the graph. When you know the slope of something and you know the y-intercept, then guess what? You have the slope-intercept form. That's how you find the equation of that particular line. Very good. The next type of equation is the point-slope form, which they give you there. And the point-slope form is y minus y1 is equal to m into x minus x1. So we have the point-slope form of that equation. We go ahead and they give us a point in that example of 3, -2, and -1 and 4. So they've given us 2 points, and we can look at them and say, I'm going to find the slope, right, using the slope formula, but I can choose which of those 2 points I use after I've found the slope. So let's pause here for a second. For the slope, the point-slope form, they've given you 2 points. You know the slope formula, which is y2 minus y1 over x2 minus x1. So you go ahead and use that to find the slope. After you find the slope, you go ahead and then plug that back into the point-slope form, right? So in doing the point-slope form, though, notice that it's y minus y1 is equal to m into x minus x1. The important thing here to note is that when you're using the point-slope formula, you select one of the 2 points. So let's say they give you this point and this point. When you're using the point-slope formula, you can use y minus 7 is equal to whatever the slope is of those values, x minus 5. Or you can use y minus 9 is equal to the slope of these values times x minus 8. Notice that as long as you're consistent, which is a big part of mathematics, is consistency. Be consistent in which values you use for your x1, y1 and for your x2, y2. It's very important for you to do that, okay? So that's how we work through those problems with the point slope form. Okay, so the point slope form is given. Just go ahead and look at the example. Use it as another tool. Write the example out for the point slope form, which is given on page 95. Okay, so they give you two examples there. Please go ahead and write those out. Those will be very good. They show you how to get the slope-intercept form and then how they convert that. Just basically moving all the x's to one side and y's to one side, and you can get the standard form of the equation of a line. They do move the constant to the left side, so that's fine. You would see that as well. Then they talk about the slope-intercept form, which is one that we've talked about quite a lot. They talk about a different one, the intercept form. So the equation of a line with x-intercept A and y-intercept B is given by x over A plus y over B is equal to 1. If we know the intercepts, we can immediately write the equation of a line. That's another strategy. This is a good bonus to have in mind. Basically, if you know the intercepts of a graph, if you know where it intersects the x-axis, if you know where it intersects the y-axis, you can literally plug it right in and get the values that you need. So that's what they do in that problem on page 96. They give you one more bonus feature, which is good, a good tool to have. Now, it doesn't hurt to have another tool, right, to use. So they do that on page 96, and they move into a very big topic, which I've discussed briefly in my other college algebra video, and that is the parallel and perpendicular lines, right? Parallel and perpendicular lines. So they give you those two. And basically you can remember that if the slope of two lines is the same, they're parallel. If their slopes are perpendicular, like if you multiply their slopes to one another, then they will have negative reciprocal. It'll be -1. So here's an example. Let me write it down. So if you multiply the slopes of two lines, you get -1. Those lines are perpendicular. So that means the slope of one of them is the negative reciprocal of the slope of the other. Or you can write it the other way around. It's just a negative reciprocal. Okay, so parallel and perpendicular lines, very important. Okay, I'm going to wrap up this video here with, they give you a few verbal sort of word problems that discuss the applications of graphing and slopes and so on. And so on page 98, they talk about in 1970, the expectancy of an American male was 67 years. In 1990, it was 72 years. Assuming that the life expectancy is a linear function, predict the linear expectancy of an American male in the year 2020. So basically what they did is they gave you, so in 1970, it was a certain age. In 1992, it was a certain age, right? I think these are the ages they gave you. So 67 and 72. So, and this is 1990. So they give you these values in 1970 and in 1990. And basically what they want you to do is solve, find the slope and then try and write the equation of a line and then use that equation of a line to plug in the new value. How do we do this problem? The difference between these two is 20 years. 20. So you say this minus this, 72 minus 67 divided by 20. So it's almost like your y2 minus y1 sort of situation. And then you basically have the difference in the years, right? Counting this as year 0, and this is year 20. So if you count 1970 as your year 0 and 1990 as your year 20, then it's basically 72 minus 67 divided by 20 minus 0, right? That's what they do there. And it gives them a slope of 1/4. That's the rate of change. There's a 0.25 rate of change, right? And so the equation of the line, and you can find the y-intercept at the 0 location, which is 67. So y is equal to mx plus b. Our slope is 1/4 x plus 67. So the rate of change of the age is 1/4, And so you put it this way, and now they ask you what would be the age in 2020. Well, what is 2020 now in reference to that 1970? It's 50 years past now. So basically, you take that 50, right? And that's the value we're inputting for x. So we put in that value for 50, and the answer actually comes out to 79.5. That's an interesting analogy, right? Think about life expectancy, which we thank God that people are living longer now, but back in the day, people would live till 35. That was more common. So imagine, think about your life. Let me think about my life too. The fact that, the Bible says, teach us to number our days that we may apply our hearts to wisdom. You need to make the most of every day. You don't know how long you have on this earth. So every day is a day to flourish. Every day is a day to say, what are the new opportunities for me to explore? How can I be better in what I do? Make the most of every day. Don't waste your time, because life is short. Fundamentally, that's just true. However, even though life is short, we've been blessed to literally almost double the amount of average time people live between 1800 and today, right? And so the 1967 to 2020 example, the 1960 to 2020 example is basically just showing us, and that's 1970, is showing us what change has happened over 50 years. And again, in reality, that's actually pretty close. I think life expectancy dropped a little bit in the past few years for males, but you get the gist. We used the equation of a line to find the information that they wanted us to find. Go ahead and write the example for this life expectancy problem, and then go ahead and write the example after that as well. I think that's a good place to stop. So in the future, we're going to talk about linear inequalities, which basically you graph them the same way you graph the equation of a line, the same thing. The difference is you shade either above the line that you draw or below the line that you draw. And we'll talk more about how to shade these graphs for the linear inequalities. Take care and have a blessed day.